Hello, everyone. This is Mr. Bryce, third period class, and people may give up on you, but you must never give up on yourself. So let's dive in. We're in Unit 3, Lesson 5, Inverses of Linear Functions, Common Core Algebra 2, the non-Regents version. If you don't understand what I'm saying, you can just scan this QR code and you listen to the genius that wrote these worksheets. Okay, now do you remember that functions have inverses that are also functions? If they're one-to-one, that means one x value has one y value and one y value has one x value, because the writing appears like magic. With the exception of a horizontal line, like when you look at the horizon, left to right, all linear functions are one-to-one, and thus have inverses that are also functions. Really? What about the vertical lines? No, those aren't one-to-one. They don't. Oh, okay. But they do have an inverse function. In this lesson, we'll investigate these inverses and how to find their equations. We have graphed over here. Y equals 2x minus 4. Along with the line y equals x. I wonder which is which because they're not labeled. Oh, there they are. There are the labels right there. How can you quickly tell that y equals 2x is a one-to-one function? So here, a function for which every element of the range of the function corresponds to exactly one element in the domain is one-to-one. Often noted 1 minus 1. No, that's 1-to-1, not the TO word. Note, y equals f of x is a function if it passes a vertical line test. Okay, it's a function if it passes the vertical line test. It is one-to-one function if it passes both the vertical and horizontal, like the horizon. If you haven't written that down, of course you already did write it down. Hit pause and write it down now. There it is right there. It passes the vertical and the horizontal line test. That noisy background is Al talking. Okay, ladies and gentlemen, anyone in the classroom, do you remember how to graph the inverse? It's a nice little silence there. Okay. Recall it's easily done by switching the x and y coordinates. So grab 2 points, any 2 points. I'm going to grab that one. And is there another one that was given to us? Sure, 0, 0. So this one up here has the coordinates 1, 2, 3, 4, 1, 2, 3. Really? Really? That's 4, 4. And that's 0, 0. So how tough is it to switch those? Yeah, not tough at all. So the inverse of y equals x is y equals x. So y equals x goes to, that little arrow means goes to y equals x. However, the y equals 2x minus 4 is going to be in blue. That's going to be tricky. That one is 1, negative 2. And that one right there is 2, 0. So we have to plot the point negative 2, 1. Negative 2, 1. And this other one is 2, 0. So that's 0, 2. Yep. And then you connect them. Connect them. And this is the inverse. That's the inverse. If I'm going to call this one f of x, and I'll call that one g of x. It's incredible. It's not perpendicular. You notice that? It's not perpendicular. So you just don't just change the slope. The slope? The slope. Don't just change them. What can we say about the graphs y equals 2x minus 4 and its inverse with respect to the line y equals x? Key! What we notice is it's reflected across the line y equals x. Do you remember that from geometry? It's reflected across the line y equals x. So that's what an inverse is. It's reflected across the line y equals x. That's the geometric definition. Find the equation. Okay. In y equals mx plus b form. Well, inverse. How do we do inverse? How do we find the inverse of the point 2, 3? Switch y and x. It's 3, 2. How do I find the inverse of an equation? Switch y and x. X equals 2y minus 4. Okay, but it says y equals mx plus b form, so we have to solve for y. Add 4. X plus 4 equals 2y. Divide by 2. Yes, y equals 1/2 x plus what? 2. Now it says find it a little easier. Why can't I just write it, Mr. Bryce? Why can't I just write it like that? You can. See, that's what it wanted you to do there. It should have asked you to do that first. Yes. So we don't know who's in the future classes because it'll be next year and the year after. If you didn't hear that, that was Al saying, hi. So this is just saying exactly what we said. You switch the x and y and solve for y. Which of the following represents the equation of the inverse of that one? Just switch the x and y and solve for y. Add 20, add 20. X plus 20 equals 5y. Now I can divide everything by 5 and see if that's one of the answers. It is not, but we do have y equals 1/5 x plus 4, because dividing by 5 is just 1/5. 20 divided by 5 is 4. Everything is divided. Nick says this problem is easy if you remember one thing about fractions. When you're dividing by 2/3, you really multiply by its reciprocal. So x equals 2/3 y plus 8. We subtract 8 from both sides. X minus 8 equals 2/3 y. When we divide by 2/3, we're really multiplying by its reciprocal. X minus 8 times 3/2 equals y. Is that any of the choices? It is not any of the choices. However, we know it's one of... Everyone is listening. It's one of those two right there. So it's definitely not this one, because the 8, let me see, 8 times 3 is 24, divided by 2 is 12. 8 times 3 divided by 2 is 12. That's Nick clapping again. What's the y-intercept to the inverse of this one? Well, you can just take the -9 of the inverse. You can just take the -9, and we know we got to flip it to the other side and then multiply by 5/3, so it's 15. Some of my students are jumping ahead, thinking that they know what the answer is. Now let's do this slowly. X equals 3/5 y minus 9, add 9, x plus 9 equals 3/5 y. That's why we know it's positive. Then we multiply by 5/3 times 9. It's 45 over 3, which is still 15. Now you guys do number 5 and check the answer. Hit pause now. The good thing about multiple choice questions is you can take a look at them and you see, oh, a whole bunch of stuff is in parentheses here. A whole bunch of stuff is in parentheses. So I'm not going to distribute. Instead, I'm going to multiply by 1/4, multiply by its reciprocal. Let's take a look at number 6. Same exact thing. Okay, now we're going to find the point. Going to find the point. So get it in point slope form. Get the answer in point slope form. So the trick, minus 8 plus 2, the y, you think the y is positive 2? No, no, no. Remember, it's x minus x and y minus y, okay? So it's not, since that says plus, how do you have a minus there? Oh, it's plus negative 2. It's plus negative 2. The answer is choice 1. That's the little stumbling block, so watch out for that. Last question. Which one of these does not have an inverse that is also a function? Well, that's a line, so we're okay with that. This is a line also. Really? Yeah, just divide by 2. So that's a line. So we're okay there. That's a line. Wait a minute. All these are lines. But you know what? Y equals 2. Let me see. That's the x-axis. That's the y-axis. Y equals 2. No, not that way, silly. It's that way. Y equals 2 is a horizontal line. Y equals 2. So a horizontal line does not have a, it has an inverse function. Its inverse function is this one right here, x equals 2. But it's not a function because it's a vertical line. Every x there has to be only one y, and every x there's bazillions of y's there. So that one does not have an inverse function. No, bazillion is not a real number. This is Mr. Bryce saying, if you're like Al, no.
You're awesome.
See ya!